All right, section 1.3 is on average rate of change. And it's pretty simple concept because it involves the slope of a line, and we've done quite a bit of work in algebra with lines and their slopes and how to calculate them. So this is sort of a review for you. We're just going to talk about the slope of the line in the context of average rate of change. So here we have, for example, coordinate plane, and we have some function. It's changing, right? It's increasing, then it's decreasing, then it's increasing. But on average, it's an increasing function, kind of like the stock market. It goes up, it goes down, it's all over the place. It's constantly changing. But on average, it's going up, right? Over a long period of time. If it wasn't on average going up, we wouldn't invest in it, right? Because we want to get some of our investment back and extra too. So that's how the stock market is. On average, it's increasing, but it changes. The function is constantly changing. So this is, let's call this point here x1, and we'll call this point down here x2. So I'm going to try and draw a straight line. Let me do this first. It's easier if I tip my paper. Okay. So the average rate of change from this point to this point is just the slope of this line. So the change in x would be x2 minus x1. That's this distance right here. And that is equal to the run. And the change in y would be from here. That's y1 is equal to f of x1. And over here, y2 equals f of x2. So this, of course, from here to here is the rise. And the rise is equal to f of x2 minus f of x1. So the difference here, so f of x2 minus f of x1 is the rise, x2 minus x1 is the run. So the average rate of change, which is the slope of that line, is equal to f of x2 minus f of x1 divided by x2 minus x1. Now you've seen something like this before. Obviously that's just how you calculate slope, but it's also the difference quotient. The difference quotient was in a little bit of a different form. Remember, that was f of x plus h minus f of x over h. Well, how are these the same? Well, let me just show you a picture. So over here, we have our function. And if I pick a point x, this is going to be f of x. And if I move a distance h, so if this distance from here to here is h, then this point is x plus h. And this distance is f of x plus h, right? You just plug it in and go over. So this is the rise. This little piece here is the rise. This is the run. So the rise is f of x plus h minus f of x, and the run is h. So it's really the same thing, it's just written a different way, okay? So let me pause here for a minute for you to finish writing, and also if anyone has a question about this, just unmute yourself if you're zooming in and ask a question if you haven't. So I'm going to, just a moment here, I'm going to look at the homework problems. There are only 7 homework problems from this section, and pretty much every problem, either you're going to calculate the difference quotient, which we already did that when we were reviewing last week. We already did that, so that's going to be review for you, or just calculating the slope using the slope formula. Either way, you all have experience doing that. So, and there are only 7 problems, so it's really not too difficult. But I'm going to go ahead and share my screen now. We're going to go to the homework. And so here we are in section 1.3. You'll notice there are only 7 problems. Here you recognize the difference quotient, and there's a table of values. All you're going to do is plug in x, plug in h into your function, into the difference quotient, and then you're going to calculate those values and enter them in. So that's just a plug and chug sort of thing. Let's take a look at this problem for a moment. This is a really good example. Remember, average rate of change is the slope of a line. So when it says, what is the average rate of change? All you're doing is calculating the slope. But what values are you going to use to calculate the slope? Well, there are 3 different average rates of change that they want you to calculate. The first one is over a period of from 1994 to 2000. Now notice that here, year is the x-axis. So from 1994, so here's 96, here's 95, here's 94. 94 to 2000 is going to be 6 years. And how is your function going to change? Well, the function is a percent. And it ranges, it starts at 0 in 1994, and the percent increases, and then it decreases a little bit. But by the time you get to 2000, you are at a height of, let's see, it looks like, it's kind of hard to see, hold on, 16. So in 0, 0 right there, you're at a height of 16. So you go from 0 to 16. That's in the vertical direction. So that is your numerator. The change in your numerator from 0 to 16 is going to be 16%. And that is over a course of 6 years. So 16 divided by 6 is going to be your average rate of change. So let me just calculate that. I'm just calculating the slope, 2.67 if I round it. In the next period of time, we're going from 2000 to 2006. So that's right here. In the year 2000, the percent of new employees is 16, and then as we go forward in time in 2006, it's going to be 21, looks like. I think that's, well, I better expand it and look at it more carefully. So we're in 2006, and I'm following this over, 20. So it's going from 16 to 20. That's 4% over 6 years. Here's the time period from 0 to 2006. That is 4 divided by 6. So that's 2/3. That's going to be 0.67% per year. Finally, in this period of time, we're going from 94 to 2006. So here at 0 and all the way over to 2006 spans 12 years. And then the function increases from 0 at the beginning in 94 all the way up to this point right here. And that is 17. So 17 divided by 12 is my slope. .42 if I round it. Oh, what did I do? Let me see. Go back to my, let's see, it was from 94 to 2006. That's 12. And then maybe I looked at my thing wrong. Hold on. So we go from 0 to, 20. I looked at the graph wrong. Hold on. Follow it over there. 20. So that's going to be 20 over 12. Let's calculate that. I don't know where I got the 17 from. I just looked at my graph incorrectly. 20 divided by 12, 1.67. Let's try that now. Nice thing about these homework, you get it wrong, you just get to do it again right away and figure out what you did wrong. Okay, let's see what the other questions are like. So here again, we're calculating the average rate of change. Notice that the change from this point to this point is only 1 for the x-axis. It moves from 0 to 1, then it goes from 1 to 2, and it goes from 2 to 3. So every time the bottom number, the run, is only 1. So that's pretty easy to calculate. You just take the rise and divide by 1, so it's equal to the rise. So for this problem, all you have to do is calculate the rise. So from 0 to 61, the rise is 61. The run is 1, so 61 over 1 is just 61. Okay. Now the next change is from 61 to 97. So there you have to calculate the difference between 97 and 61, and that's just 36 over 1, which is just 36. So you can see how this works out. It's pretty simple to do. Okay, so I'll let you finish that on your own. And the other problems are similar. You're just plugging in numbers here into your function. Here's the function given to you. You're just plugging in 5 and 15 and then calculating the slope that way. Same here. And then finally, this one, same thing. You've got your function. You plug in 6 and 3, or 9 in this case, 6 and 9, which gives you 3, is the difference. And so you calculate the rise over the run for that. So that's all you're doing. Here is the difference quotient again, just like the first problem. You're just plugging in numbers. So that's a pretty straightforward assignment. And that concludes our material for this week. So your homework for this week is due Monday night at 11:59 p.m. And you've got 4 assignments, 3 homeworks, and 1 quiz, which covers all 3 sections. 1.1, 1.2, and 1.3. The homeworks 1.1 and 1.3 are pretty simple and straightforward and short. 1.1, which dealt with graphics, limits with graphs, is kind of tricky, but easy to do as far as time-wise. 1.2 might be a little bit more lengthy, but allow yourself plenty of time to take the quiz. You don't want to wait until the deadline to start taking the quiz, because you want to allow yourself multiple tries so that you can replace your low score with a higher score.